Hi, in today's lab, we will be preparing a dye laser, or some people call it a laser dye. These are organic molecules that emit fluorescence when they are hit by external lasers. And I have explained to you in my PowerPoint how they do that. I've also explained to you actually the mechanism of this reaction as well. So you should watch that, my PowerPoint presentation as well. And so in today's lab, there will be two reactants. One will be an aldehyde, specifically NN diethyl amino salicylaldehyde, and another reactant needed for this reaction will be ethyl acetoacetate. When they are hit together in the presence of a weak base like piperidine, a secondary amine, you get two reactions. One is Navier-Stokes condensation reaction, and the other is trans-esterification reaction. Navier-Stokes and trans-esterification reaction, and these two reactions occur in the same pot. So what is a condensation reaction? It's any reaction in which two molecules make a bond, and when they make a bond, some small molecule like water comes out. That's a condensation reaction. So this is an example of a condensation reaction. It's also an example of a trans-esterification reaction. So condensation means, in this particular Navier-Stokes condensation reaction, there's an aldehyde. We have aldehyde group here. This is a diethyl amino group, tertiary amine, which does not participate in this reaction. This is phenolic OH. This does participate in the reaction. Aldehyde group does participate in the reaction, and active methylene group. Active methylene is methylene is CH2. When CH2 group is flanked by sandwiched by two carbonyl groups, we call it active methylene, and that makes actually the two carbonyl groups make these two hydrogens acidic, quite acidic. So much acid, even weak base can actually pull up the proton like that. So this is the nucleophile, and this is the electrophile, and you make a bond between this carbon and this carbon, so you have with this bond a new bond forming reaction occurs, and you have split out a water molecule. So this is a condensation reaction. Now, as I said, this also participates in the reaction in this part of the product molecule. So what is trans-esterification reaction? This is any reaction in which one ester group is substituted by another ester group. See here, this is not a cyclic ester, this is an open chain ester. This is also an ester group, however this is present in the ring, and therefore it's a cyclic ester. Cyclic esters are also called lactones. Lactones are esters basically, but they are just cyclic esters. Okay, so we have actually exchanged one ester group with another ester group. So this is a trans-esterification reaction. So both these, first condensation occurs, Navier-Stokes condensation, and then after that the cyclization occurs, which is trans-esterification reaction. So what we'll be doing today, we'll be mixing these two reactants, and diethyl amino salicylaldehyde with ethyl acetoacetate, and we will add, this is a catalyst actually, we need a certain few drops of piperidine, and we will be getting condensation and trans-esterification reaction, and we'll be synthesizing a laser dye. Okay. Now we will not be taking this laser dye and dissolving it in some solvent and hitting it with an external laser. We're not going to do that. Our job is only to synthesize it. Okay. So let's go ahead and head to the lab to synthesize.
Okay, we are in the lab, and let me introduce to you some of the chemicals that we'll be needing for this reaction. This is piperidine. It's a base, it's a mild base, secondary amine, that is required for Navier-Stokes reaction as a catalyst. Now this is N-diethyl salicylaldehyde. That's the carbonyl partner for the Navier-Stokes reaction, and this is ethyl acetoacetate, the active methylene compound. Active methylene compound has acidic protons that are removable by the mild base piperidine. Now I have already weighed 1 gram of the N-diethyl salicylaldehyde, and I'm going to put it in a round bottom flask using a powder funnel. Always use a powder funnel for adding solids. And now the second reaction partner is active methylene compound, ethyl acetoacetate. That's what I'm going to add. So two reactants are already in there. Now what we are going to do is add the catalyst, the mild base, piperidine or piperidine. That's it. And we were going to add about several drops of this into the round bottom flask, and that's it. We have added everything now, and that's required for this reaction. So we're gonna magnetically stir it with the magnet bar for about 20 minutes. So turn the 20 minutes, but it probably will not dissolve at room temperature. We may have to actually heat it a little bit, warm it actually, not heating but warm. This reaction should take place at room temperature, but it requires a little bit of solution, just a softening of the reactants. So use water in a small beaker and warm it very low, using a low heat. As soon as the solution occurs, the whole thing dissolves, then remove it from heat. So I've been stirring the reaction mixture for about 40 minutes. During this time, this has become a gummy mass, which is difficult to stir with the magnet bar. Magnet bar is stuck in there. The reaction is complete. So I basically need to add some solvent to it, not to dissolve, but to just to disengage it from the flask, to make it a little bit softer and easier to swirl. I could filter it under suction, but the particles are very small and therefore they will go through the filter paper right away. So I need to reflux it. By heating in ethanol, the purpose is to let the smaller particles coalesce together to become bigger particles so they can be easily filtered through suction. So that's the purpose of it. So I will just boil it for about 5 minutes and then I'll be ready to filter it. Okay, I have been refluxing this solution for about 5-6 minutes. The purpose was to convert a very fine precipitate into a coarse precipitate containing bigger particles, because I knew I could not filter fine particles. So a lot of people try to actually heat it in some solvent to coagulate smaller particles into bigger particles. Now you can see the precipitate there. Now we want to get more precipitate. For that we need to put it in chilled water. So when you reduce the temperature, the solubility of your product decreases and you get more precipitate, more product. Now these are very nice crystals, and now we want to actually filter it. When you filter it, you transfer a lot of that. First of all, you need to actually, before filtering, you need to wet the filter paper with the solvent, in this case alcohol. Transfer as much of the product as much product as you can, and there's always a little bit left in the flask, and therefore don't want to rinse it. The purpose is now to actually stop the filtration and add the rinse to it. Add the rinse and agitate it a little bit, make a circular motion, make sure all the crystals are completely covered by the rinse, and you keep it there for about maybe half a minute, and just assume that the crystals have been washed to some extent, and then turn the vacuum on again. And when you turn the vacuum on again, the rinse goes into the filtrate. You can do that. You can repeat the process of rinsing a couple of times just to make sure that your product is more pure and all the impurities have gone into the flask. You can see the colored impurities are in the flask. and the stuff that remains on the filter paper is beautiful golden yellow crystals. Okay, you can see that, very nice crystals and beautiful crystals. And you can imagine that when they are excited, they will be uh, giving out their own lasers by fluorescence. Okay, so you have basically synthesized the laser dye containing coumarin as an important part of the molecule. Transfer the whole thing, transfer your product as much as possible from the Buchner funnel onto the watch glass. And by the way, the filter paper and watch glass should have been pre-weighed, because now you are going to find out the yield of your product. Always pre-weigh watch glass with a filter paper. Now we are going to calculate the yield. The mass of watch glass plus filter paper is 49.52, and the mass of the watch glass plus filter paper plus laser dye is going to be 50.66 gram. If you subtract the lower number from the higher number, you get the mass of the product, 1.14 gram. Now remember, the stoichiometry of this reaction is 1 to 1. Therefore, find out the dimensional analysis equations, which one the limiting reagent. Based on that, you can calculate the percentage yield for this reaction. Bye-bye.